This is our first lesson on proofs with angles. They are very, very similar to proofs with segments. It's just kind of a different section in our textbook. So first, let's start with some definitions that we need. The angle addition postulate is really, really similar to the segment addition postulate. It just says that if I have two small angles that are adjacent to each other, they can add together to make a bigger angle. So in this picture, the measure of angle ABD, the red one, plus the measure of angle DBC, the blue one, equals the measure of angle ABC. That's when we put them together. And then the two theorems at the bottom, the supplement theorem just says if two angles form a linear pair, then they are supplementary angles, which we kind of already knew. So in this picture, angle 1, angle 2 add up to be 180. And similar to that, the complement theorem just says if two angles share a side, they're adjacent, and they form a right angle, then those angles are complementary. All right, now we're going to take all these and we're going to put them in a proof. So here I want to write a 2-column proof. So I'll start by making a table for my statements and my reasons. My first statement is always the information that I'm given. So angle ABC is a right angle. Reason is that it is given to me. I want to somehow get down to a point where angle ABD and angle CBD are complementary. In order to show that two things are complementary, I have to show that the two angles added together equal 90. So I want to somehow in my proof get an equation, get an equal sign in play so that I can show that two things added together equal 90. Well, I'm going to take the fact that angle ABC is a right angle, and from that, I'm going to say that the measure of angle ABC equals 90. Notice when I put an equal sign in there, I have to add an M in front of that angle to show it's the measure. So how did I go from ABC as a right angle to the measure of angle ABC equals 90? Well, doesn't look like I see it here. So maybe let's say that's the definition of a right angle. Remember, we can use any definition that we know as a reason. We like having postulates and theorems because they're shortcuts. They're typically faster to write. But we can say that is the definition of a right angle. Perfect. Now I have that the measure of angle ABC equals 90. In order to show things are complementary, I want to show that two angles added together are 90, so I have to get a plus sign in here somewhere. Well, that's where I'll jump back to my theorems and postulates. It looks like if I can use the angle addition postulate somehow, I could get a plus sign into play. So let's do that. In this picture, I see the angle addition postulate where this angle and this angle add up to be the whole angle. So let's say the measure of angle ABD plus the measure of angle CBD equals, not 90, I'm jumping ahead of myself, equals our large angle. So angle ABC. That's an example of the angle addition postulate. So now I'm going to take my previous two statements and I'm going to kind of put them together. I'm going to take the fact that the measure of angle ABC equals 90 degrees, and the fact that I know the measure of angle ABC is this whole big thing, the measure of angle ABD and the measure of angle CBD, and combine those two. So I'm going to make the statement that the measure of angle ABD plus the measure of angle CBD equals 90 degrees. I took two things and I combined them, or you could say I took the green equation and I substituted in the measure of angle ABD plus the measure of angle CBD. So the reason there is substitution. Technically, it's the substitution property, but I think substitution is clear enough. And now that we have two angles adding together to be 90 degrees, we can come back to our complement theorem. The complement theorem says two angles added together equals 90 degrees is basically the definition of being complementary. So, on my proof, I'll say, and remember, you always have to end a proof with word for word what we are trying to prove. So the blue statement that I have right now, yes, it basically is showing the angles that are complementary, but it's not quite enough. I have to actually write out angle A, B, D, and angle C, B, D are complementary. And the reason there is that theorem, so the complement theorem. Remember, you can also use any definition you know as a reason. So if you wanted to say the definition of complementary, if you couldn't remember the complement theorem, that works. It's just a couple more words. So proof like this is kind of the point I'm expecting you to be at right now. On your quiz for this section, it's not going to be doing a whole proof by yourself. It'll be something like this where you're given most of it and you're filling in like 3 or 4 blanks. So I'm going to kind of walk through our strategy on doing this. Angle 1 and angle 3 are complementary. 2 and 3 are complementary. That is my given statement. My first reason is always given. Let's kind of label our diagram. We know angle 1 and angle 3 are complementary. So these two guys add up to be 90. We know angle 2 and angle 3 are complementary. So these two guys add up to be 90. And we're trying to show that angle 1 and angle 2 are congruent. So I've got my first reason taken care of. To figure out my next reason, I'm going to ask myself, how did the person who wrote this proof go from A to B? Well, they went to a sentence that has the word complementary in it and then on to something that has a plus sign in it. We actually just did something like that, but we went the other way. We went from the thing with the plus sign to having the word complementary. And when we did that, that was the complement theorem. Again, any definition you know works. So you could say the definition of complementary there. From C, it looks like we took those two equations, angle 1 plus angle 3 equals 90, and angle 2 plus angle 3 equals 90. And we said, hey, they're both equal to 90, so let's set them equal to each other. That is an example of substitution. The next thing has us use the reflexive property. The reflexive property is just when something is equal to itself. So let's say here that the measure of angle 3 is equal to the measure of angle 3, because see, this equation has the measure of angle 3 on both sides. I probably wouldn't have written this step if I were writing the proof, but since it's a fill in the blank, we kind of have to work with what they gave us. And then we're going to ask, how did I get from what I've got previously to the measure of angle 1 equals the measure of angle 2? It looks to me like they took this equation and they subtracted the measure of angle 3 from each side. And we can do that because that's just a number. So that was an example of the subtraction property of equality. I'm just going to say subtraction. And then we went from something with an equal sign to a congruent sign. Anytime we go equal to congruent or congruent to equal, that is the definition of congruency. So we actually just proved one of the cases of theorem 2.7. That theorem is either called the congruent supplements theorem or the congruence complements theorem. There are two cases of it. This just basically says if I've got 3 angles and I have 2 sets of supplementary angles, so here angle 1 and angle 2 are supplementary, and angle 2 and angle 3 are supplementary, then angle 1 and angle 3 are congruent. So it's kind of an example of the transitive property. You can do the same thing with complementary angles. If 4 and 5 are complementary and 5 and 6 are complementary, then 4 and 6 are congruent. That's not a very common theorem. I think we'll use it like maybe once or twice this week, but it's not one that I expect you to know off the top of your brain. And then one final definition we'll need is the vertical angles theorem. When you read through it, it's something, again, that we already know. If 2 angles are vertical, then they are congruent. It's just nice to have the vertical angles theorem rather than having to write out the definition of vertical angles in a proof.